Alright, so now we're doing problem 7. So problem 7 reads, the relative extrema of f of x equals x cubed divided by x minus 4 occur at which of the following? So we want to look for the relative maxima, or maxima, at x equals something, and relative minimum, or minima, at x equals something. Alright, so in order to find the relative max and mins, we need to do the first derivative test. That means we need to find our critical points. Okay? But, quick recall of critical points. The possible critical points are the x values that make the derivative equal to 0 or undefined. But if the function is not defined at the x value, then it is not a critical point. So, what we need to do is find the first derivative, find out when the first derivative is equal to 0, and find out when the first derivative is undefined. So that means that we must equal the numerator, we must make the numerator equal to 0 and make the denominator equal to 0 to find out when it's equal to 0 and when it's undefined. Alright, so first let's find the first derivative. So, f prime x. Alright, so first of all, let's do some work here. F of x is equal to x cubed divided by x minus 4. Alright, I'm going to change this into x cubed x minus 4 to the negative 1. In order to find the derivative of this, I must use the product rule. So, f prime x is therefore 3x squared times x minus 4 to the negative 1 plus the derivative of x minus 4 to the negative 1, that's negative 1 x minus 4 to the negative 2 times x cubed. Alright, that's f prime. Let's rewrite f prime. So let's simplify this. So, just one step calculus, the rest is now algebra. Alright. So this is 3x squared divided by x minus 4 plus, or minus, so minus x cubed divided by x minus 4 squared. Okay, so let's work this out a little bit more. We have x minus 4 squared. I want to go ahead and combine these two fractions. In order to combine these two fractions, I need the LCD. So this guy right here, it's missing an x minus 4, so I got to multiply the numerator and denominator by x minus 4 to get an x minus 4 squared here. So therefore, f prime of x is equal to 3x squared times x minus 4 minus x cubed, all that divided by the LCD that we just found, x minus 4 squared. Alright. Let's do a little bit more. Let's go ahead and distribute this and simplify. So finally, f prime x is equal to 3x squared times x is 3x cubed minus an x cubed is 2x cubed. So we have 2x cubed. And then we have 3x squared times minus 4, that's minus 12x to the squared. Alright, and that's all divided by x minus 4 squared. X minus 4 squared. Alright, so now we have our first derivative. Now we want to go ahead and equate this to 0, so we want to find a critical point, so we need to make the numerator equal to 0 to find out when it's 0, and we need to find when it's undefined, so we need to make the denominator equal to 0 as well. So then, 2x cubed minus 12x squared equal to 0, and x minus 4 squared is equal to 0. Okay, so let's solve this one. Go ahead and factor out an x squared and a 2. So we have 2x squared left with x minus 6, and that's equal to 0. Therefore, x is equal to 0, and x is equal to 6. And here, we solve this, we get x equals to 4. Okay. So, these are our possible critical points. Now you want to go ahead and make this equal to 0. Or sorry, now you found these critical points, you want to go ahead and see if they're defined. So define at the original function. So f of let's go ahead and do 0 first. Is 0 defined? Yes, that's 0. What else do we have here? We have 6. So 6. Is 6 defined? Yes, it is defined. It's a number. We want to see if it's defined or not. And f of 4. F of 4. 4 minus 4 is 0. It's not defined because that's divided by 0. So that's not defined. Does not exist. Alright, so let's scratch that out. So we only have 0 and 6 are as our critical points. Okay? So once we have that, let's go ahead and erase this. I can write that down. The important information is that we have our critical points. So therefore, critical points are x equals 0 and x equals 6. Alright. Alright, so now that we have our critical points, let's go ahead and draw our number line. Alright, our critical points are 0 and 6, so put 0 here, put 6 here. Now, we want to find a relative max and min. So we want to see if this is decreasing, increasing, decreasing, increasing, or what's happening in between here. So how do we do that? We get test points. So -1, we get -1. I'm going to get 1, and I'm going to get 7 as our test points. So now with our test points, we're going to go ahead and plug in the test points into the first derivative. So our first derivative is right here. So plug the test points, and we want to see, we don't care about the number, we just want to see if it's negative or positive. So I want to simplify this a little bit more. Let's go ahead and factor out the 2x squared left with x minus 6. And we have an x minus 4 squared. So I'm going to go ahead and plug them in here. So f prime of -1. Alright, so f prime of -1. So testing test points. Alright, so f prime of -1. So f prime of -1 is what? We have 2 to the -1, that's going to be a positive, right? -1 minus 6, that's a negative. A negative times a positive is a negative. And then down here we have -1 minus 4, but it's always squared, so this is always going to be positive. So a negative divided by a positive is negative. So it is a negative number. If it's a negative number, that means this is decreasing. So we have a negative slope, it's decreasing. So f prime now at my other test point, 1. So come back here, plug 1. We get 1 minus 6, that's a negative number. That's a positive number. Negative times positive is negative. And down here it's always positive. So negative divided by positive is another negative number. It's a negative number. Alright. Last but not least, f prime of 7. Well, that means this is also decreasing. Alright. F prime of 7. Plug in 7. 7 minus 6, positive number. 7 squared times 2, positive number. And that's a positive number. So positive divided by positive is positive. So we have a positive number. So therefore, this is increasing. Alright. So if you look at this, this is decreasing, decreasing. And this comes from decreasing to increasing. So there's a minimum right here at x equals 6. Because in order for this to decrease and then increase, it must do something like this. So we know it's a minimum, but there's no maximum here. So a relative minimum is at x equals 6, and at x equals nothing, so it does not exist. Because there is no maximum. So relative minimum is at 6, and relative maximum does not exist. To recap a little bit here, okay, we want to find the relative max and minimums. In order to do that, we must find the first derivative and find our critical points. Our critical points are those points that equal 0 or make the derivative undefined, and those points must also be defined for the original function. If they're not defined, then they're not critical points. So we found one point here, x equals 4, that's not defined in our original function. So it cannot be included in our critical points. Our only critical points are those that we found and were defined at f of x. Okay, so once we have those points, we draw our number line. We go ahead and pick test points. I pick -1, 1, and 7. We evaluated those test points into our first derivative, and here we're just looking at if it's increasing or decreasing. Because we know if it's decreasing and increasing, we have a minimum. If it's increasing and decreasing, we have a maximum. So in this little picture here, it's decreasing and increasing, so at 6, that's a minimum, and there is no maximum. So, that's that.